Hello guys, welcome back to my channel. In this video we'll be looking at the factor theorem. Okay, so if you are new to this channel, please remember to hit the subscription button below and put on the alarm so you receive a notification whenever we drop another video. And please don't forget to introduce your friends, your colleagues in the school to this channel. God bless you. So at the end of this lesson, we should be able to state the remainder theorem or the factor theorem as another form of the remainder theorem, and you should be able to apply it, that is, show that a particular expression can divide a polynomial or expression without a remainder. Okay, and that is called the factor theorem. So this is the factor theorem. So this theorem here is called the factor theorem. Okay, the factor theorem states that if when p of x is divided by x minus a, the remainder is 0, then x minus a is a factor of p of x. So if p of a equals to 0, then x minus a is a factor of p of x, right? That is what it says. It's just a form of a remainder theorem. If you don't know the remainder theorem by now, guys, please watch our video on remainder theorem by clicking the link below in the description button below. Okay, now so this is what we have seen here. If you pick this particular example, remember the last two examples we gave in our video on remainder theorem, the remainder of all those examples were zeros. Okay, so it then shows that the divisor is the factor of the given polynomial. Okay, and remember we said that if p of x equals to x minus a multiplied by q of x plus r of x, okay, then if x minus a equals to 0, then x equals to a. So if you put a for x here, you have a minus a into q of x plus r of x. So and that will be 0 multiplied by q of x plus r of x, and that will be 0 plus r of x, okay, which is r of x. So that means p of a equals to r of x. Now we are now saying that if p of a equals to 0, then x minus a is a factor of f of x, or p of x rather. Okay, that is the remainder theorem. So let's see the application in the following example. Example 1. Verify that the first polynomial is a factor of the second polynomial. Okay, remember we will not use the long division method. Okay, we will use the method we've been using from remainder theorem to check, okay, which is shorter than using the division algorithm. So for a, we have p of x to be the second polynomial 3x cubed plus 5x squared minus 4x minus 4. Okay, and the divisor is x minus 1. Now if x minus 1 equals to 0, you have x equals to 1. Okay, and then p of 1 equals to 3 times 1 raised to power 3 plus 5 times 1 squared minus 4 times 1 minus 4, which is 3 plus 5 minus 4 minus 4, which is 8 minus 8, and which is 0. Okay, so here p of 1 equals to 0, then it automatically implies that x minus 1 is a factor of p of x. Okay, and that's it, guys. Very simple. So for b, can do the same thing for b. P of x here is 4x cubed plus 3x squared plus 9x plus 10. So d of x, which is the divisor, is x plus 1. Now let x plus 1 equals 0, so that will give us x equals to minus 1. So now let's find p of minus 1. Substitute minus 1 for x in p of x, and we have 4 times minus 1 raised to the power 3 plus 3 times minus 1 squared plus 9 times minus 1 plus 10, okay, which is minus 4 plus 3 minus 9 plus 10, okay, and this is minus 4 plus 3, which is minus 1, so this is minus 10 and plus 10, and this is 0. So p of minus 1 equals to 0, and it then implies that x plus 1 is a factor of p of x. Okay, so this is how to show that a given polynomial is a factor of another polynomial by using the factor theorem. Use the factor theorem, example 2. Use the factor theorem to find all the linear factors of the following polynomials. Now, this is called the integral zero method, or we call it rational zero. Okay, so we are going to be using the what we call the trial and error method. Okay, the trial and error method. Okay, so remember here that if p of x is divided by let's say a polynomial is divided by a polynomial, let's say of degree 2, let's say degree 2, okay, of degree 2, then the factors can be written as x plus or minus a, x plus or minus b, okay, so x plus or minus b, okay, and the constant term, the constant is going to be, the constant is going to be plus or minus this guy here. The constant here is going to be plus or minus ab. Now if you want to use the factor theorem to find the factors of this expression, okay, you will find the factors of the constant, then we use the integral zero method or the trial and error to check if these factors of the constant will give you a remainder of 0 when you substitute for x in a polynomial. Okay, so now let's consider the first example. Example 1, p of x here plus p of x equals to x cubed plus 3xy minus 6x minus 3, okay, and yeah, so the constant here, the constant is minus 8, okay. What are factors of minus 8? Factors of minus 8 are plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8 itself, okay. So now we check which of these factors will give us a remainder of 0. So we check which of these factors it will give us a remainder of 0. So we say when x equals to plus 1, let's start with plus 1, p of 1, substitute into the polynomial, we have 1 plus 3 minus 6 minus 8, which is 4 minus 14, which is minus 10. So here shows that x minus 1 is not a factor. So if you substitute and you don't have 0, then it implies that that particular one is not a factor. So we'll go ahead and pick minus 1, okay. So when x equals to minus 1, so substitute into the polynomial, we have P of minus 1 equals to minus 1 raised to power 3, minus 1 raised to power 3 plus 3 into minus 1 squared minus 6 into minus 1 minus 8. Okay, let's cross check if we are right here. So this will give us 1 plus 3 plus 6 minus 8, and this is 10 minus 8, which is 2. So this one is not equal to 0 as well, so it implies that s plus 1 is not a factor. So we check for x equals to 2. So what will be p of 2? P of 2 will be 2 raised to power 3 plus 3 times 2 raised to power 2 minus 6 times 2 minus 8, and this is 8 plus 12 minus 12 minus 8, and this is 20 minus 20, which is 0. Thank God this is 0. So here we can state that right away that x equals to 2, then x minus 2 equals to 0, so x minus 2 is the factor of p of x. Okay, so that is the first step here. Now the second step is to use the long division to find the remaining factor. Okay, you use the long division to find other factors. So you can continue using this try and error method if you want, but to make it shorter, since we are getting one factor, you use the division algorithm to find the other factor to make your work faster, and that will give us so the division here is what we used was x minus 2. Okay, x minus 2 is going to be the divisor. So the polynomial is x cubed plus 3x squared minus 6x plus 3x squared minus 6x minus 8. So x in x cubed, we have x squared, multiply, we have x cubed minus 2x squared, and then if you subtract, you have 5x squared minus 6x, and if you divide that, x and 5x, you have plus 5x, multiply, you have 5x squared minus 10x, and then if you divide, subtract again, you have plus 10 minus 6, that will give us 4x minus 8, so x and 4x, we have plus 4, so x times that, you have 4x minus 8, and then when you subtract this one, you have 0. So this can be factorized to give x plus 5x plus 4 can be factorized to give if you multiply the first and the last, you have plus 4x squared. Okay, what two number can you multiply to have plus 4x and add to have 5x? That will be plus x and plus 4x. Okay, so if you factorize this by giving, you have x squared plus x plus 4x plus 4, and that will give you x into x plus 1 plus 4 into x plus 1, and which is x plus 4 x plus 1. Okay, yeah, so therefore we can write the whole of this expression to be we have x cubed plus 3x squared minus 6x minus 8 equals to the product of x minus 1 multiplied by x squared plus 5x plus 4, which is the same thing as x minus 2 into x plus 4, x plus 4 into x plus 1, and that is the answer, guys. That is the answer. So this is how to use the factor theorem to find all the factors or the factors of a given polynomial. Let's take example 2. X cubed minus 7x plus 6. X cubed minus 7x plus 6. be x cubed minus 7x plus 6. Okay, so let's say p of x equals to x cubed minus 7x plus 6. Okay, so the constant first, the first step is to take the constant. The constant here is plus 6. Okay, so find the factors of plus 6. Factors, we have plus or minus 1, plus or minus 2, plus or minus 3, and then plus or minus 6. So we check using trial and error or the integral zero law to find which of this will give us a remainder of 0. So check starting from x equals to 1. We have p of 1 equals to 1 minus 7 plus 6, which is 7 minus 7, which is 0. So x equals to 1, and then x minus 1 equals to 0. So x minus 1 is a factor. Is a factor of p of x. Okay, so we can now use the division algorithm to find other factors. So use division algorithm now. Division to find all other factors. So this will give us we are going to divide now. The dividend will be our polynomial expression x cubed minus 7x plus 6, and the factor x minus 1. So x in x cubed, we have x squared. So multiply, you have x squared minus x squared. So if you subtract this expression, you have x squared minus 7x, and then multiply or divide x squared by x, we have plus x. So if you multiply, we have x squared minus x, and if you subtract here, we have minus 7 plus 1 of minus 6x. Then we can bring down 6. So x here will give us minus 6, multiply, we have minus 6x minus 6, and then if we subtract, we have 0. So, and then if we factorize x squared plus x minus 6, it will give us x minus 2, because we have x minus 2 and plus 3. Yeah. X minus 2 and x plus 3 as the factor of that. So in summary, we can now write a polynomial expression. So therefore, x cubed minus 7x plus 6 can be written as the first factor, which is x minus 1 into x minus 2, x minus 1 into x minus 2 into x plus 3 are the factors of that, and that is that, and we've answered all the question. Okay, so it's very easy and straightforward. This is how to use the factor theorem to find all the linear factors of polynomial expression. Use the trial and find the factors of the constant, then substitute all the factors, find which of the first factor that will give you a remainder of 0. So that shows that it is a factor. Then you use the division algorithm, the long division, to find other factors, and then you can write the polynomial as a product of the factors, and then you are done. The last example here is the last one. Let's see. If x minus 3 is a factor of 6x cubed plus kx squared plus 2x plus 3, find the value of k. Okay. So we said that, let's write down the polynomial. The polynomial p of x is 6x cubed plus kx squared plus 2x plus 3. Okay. Then of the divisor, which is the factor, is x minus 3, and since x minus 3 is the factor, let's say x equals to 3. So let's find p of 3. P of 3 equals to 6 times 3 raised to power 3 plus k times 3 raised to power 2 plus 2 times 3 plus 3. And this is 3 raised to power 3 times 29 times 2 is 27. 27 times 6 will give us 6 times 7, which is 42. Therefore, 6 times 2, 12. 12 plus 4, we have 162. So this is 162 plus 9k plus 6 plus 3. And this 6 is 6 plus 3, which is 9 of 169, 171 plus 9k. Okay, let's call this equation 1, p of 3. So remember that if x minus 3 is a factor of 6x cubed plus this, find the value of k. Remember that since x minus 3 is a factor, of p of x, then p of 3 will be equal to 0. Okay, so we can use the fact to now find so using this fact we can say that p of 3 equals to 0 implies that 171 plus 9k will be equal to 0. Okay, so 9k equals to minus 171. Take it to the other side there, and divide both sides by 9. 9 goes to 9, therefore k equals to 9 here 1, 9 and 17 we have plus 1, 9 in 81 we have 9 minus 19, so k equals to minus 19. Yeah. Very simple. Another example, find the values of, this is 4 guys, the last one was 2. Example 4. Okay, this is example 4. Find the values of a and b if x minus 1 is a factor of g of x equals to ax4 minus 5x2 plus b, and when g of x is divided by x plus 2, the remainder is 135. We are looking for a and b. So since let's write down g of x. G of x equals to 8x raised to power 4 minus 5x cubed plus b. Okay, now we're told that x minus 1 is a factor. Of g of x. Okay, from the equation, so it implies that x equals to 1 and that g of 1 equals to a minus 5 plus b. Okay, which is equals to 0. So a minus 5 plus b equals to 0 because x minus 1 is a factor, so g of 1 will be equal to 0. So a plus b equals to 5. Let's call this equation 1. Now from the second part of the sentence, and when g of x is divided by x plus 2, the remainder is 135. So when it is divided by x plus 2 goes to 0, so we have x equals to minus 2. So let's find p of 2. So p of 2 will be a times 2 raised to power 4 minus 5 times 2 raised to power 3 plus b, so, which is 16a minus 2 raised to power 3, which is 8 times 5, 40 plus b. Okay, so we have 16a. So that implies that 16a plus minus 40 plus b equals to 0 equals to 135. Okay, because p of 2 is 135. Okay, so if we add 40 to both sides, we have 16 plus b equals to 135 plus 40. So 16a plus b equals to 175. Okay, let's call this equation 2. So now we can now solve equation 1 and 2 simultaneously to find a and b. The first equation says a plus b equals to 5, equation 1. Then 16a plus b equals to 175, equation 2. Okay, let's cross check whether I copy correctly. Yeah, it's correct. So if we add let's say to subtract equation 1 from 2, we have 16a minus a will be 15a, b minus b will be 0, 175 minus 5 we have 170, and then we can divide both side by 15. So 15 will go in 15, 5 we have 3, 5 in 17 we have 3 times 3 of 15, 5 in 20 we have 4, and then 3 here 1, 3 here 1, yeah, it cannot go. So therefore a equals to 34 over 3. Okay, now finding b, substituting 1, we have 34 over 3 plus b equals to 5. So b equals to 5 minus 34 over 3, and this is 15 minus 34 all over 3, so that b equal to 15 minus 34 is minus 19 over 3. So therefore a equals to 34 over 3 and b equals to minus 19 over 3. And let's solve the problem. Okay, the next example, which is the last example, example 5. So this is example number 5, guys. X plus 1 is a factor of f of x equal to x cubed plus mx squared plus nx minus 3. And when f of x is divided by x plus 2, the remainder is minus 24. So find m and n. So now let's write down our expression. F of x equals to x cubed plus mx squared plus nx minus 3. And since x plus 1 is a factor, so equals to 0, x equals to minus 1, so it implies that f of minus 1 will be equals to 0, which implies f of minus 1 equals to minus 1 plus n minus 3 equals to 0. That implies that m minus n minus 4 equals to 0. So we have m minus n equals to 4. Let's call this equation 1. Then equation 2. The second part of the statement says when f of x is divided by x plus 3, the remainder is minus 24. So x plus 3 equals to 0, x equals to minus 3. So f of minus 3 equals to minus 24. That is f of minus 3 equals to minus 27 plus 9m minus 3m minus 3 equals to minus 24. So we have 9m minus 3m minus 30 equals to minus 24. So 9m minus 3m equals to minus 24 plus 30. So 9m minus 3m equals to 6. So divide all through by 3. We divide all through by 3. We have 3m minus n equals to 2. Let's call this equation 2. So we can solve equation 1 and 2 simultaneously to find m and n. The first equation says m minus n equals to, let's check correctly, equals to 4. Equation 1. Second equation says 3m minus n equals to 2. Equals to 2. So we can subtract equation 2 from equation 1 to have minus 2m equals to 2. So dividing this by minus 2, we have m equals to minus 1. And substituting there, we have minus 1 minus 8 equals to 4. So minus n equals to 4 plus 1. So minus n equals to 5. And then n equals to 5. Okay, so therefore we can conclude that n equals to minus 1 and n equals to minus 5. It's minus 5. minus 5, guys. So this is minus 5 as the values of m and n. And guys, this is how to use factor theorem. I believe you understand. If you understand and like our video, please remember to hit the subscription button. See you in the next series. Bye.